Hi, I'm Sébastien Ferré from the University of Rennes. In this poster, I will propose an extension of SPARQL 1.1 with nested results. So first, on the left, I will show the behavior with the standard SPARQL, and this will be illustrated on a query retrieving the music composers and the actors of Danny Boyle's films. So first, the standard query. So it retrieves films having director Danny Boyle. It retrieves their music composers, their actors, and it also retrieves the birth year of the actors. So as expected, we get this table as results, so with 4 columns, film, music composer, actor, and birth year, and we get 1 row for each result to the query. So as we can see, there are some drawbacks in this presentation of results. For instance, there are many repeats of the same terms. The same film is repeated several times, and the same happens for some music composers and for actors. There is also a loss of structure from the graph. So for instance, we can see that there is a column with a birth year, and we don't really know if this birth year is about the actor or about the music composer. Another problem is that there is a combinatorial growth of the number of results. So for instance, here the number of results will be the number of films times the number of music composers per film times the number of actors per film. So all those drawbacks, they come from the 1NF first normal form, which impose to have atomic values in cells. So what I propose is to have instead nested tables of results. So on the right we have such a table of results where some cells in the table may contain nested tables, which in turn may also contain nested tables. So here the benefits is that this enables to have a single row per film, which makes the result much more compact. And for music composers, for instance, we have nested tables that contain the list of music composers for each film. So an additional benefit is that there are no more repeats from one row to the next. Each film appears once, each music composer appears once, and the same for actors. We can see that the nested tables, they are not only lists, they can be tables with several columns, like here about actors, because the birth year is dependent on the actor, and so each birth year is given on the same line, on the same row as the actor. It also exhibits more structure, showing dependencies and relationships between columns. So for instance, here in this nested table, it is clear that the birth year is about the actor, not about the music composer. So what we have done here is to group results, to project the results on some columns, removing duplicates, ordering. So they suggest the solution for the extension, which is to use solution modifiers as aggregators. So this is what is done in the query, in the proposed extension. First, there is a group by clause to group results by film. So this has to have a single row per film. And then we have a column MCS, which stands for music composers, which is in fact obtained by a kind of subquery. We use a select distinct MC to collect all distinct music composers for each film. Similarly, for actors, we have a select distinct actor year, and we can also use an order by clause. So here we order each list of actors by increasing birth year, which can be checked here. So 1959, 1984, 1990. Okay, so actually all solution modifiers can be used here as aggregators. So select for projection, distinct for removing duplicates, ordering, offset and limit can also be used. Okay, and so this requires an extension of the SPARQL language, but this has already been implemented in an existing tool, which is SPARQLIS, in which the results, they can be shown in a standard table like this, and also as a nested table, which is much more readable. If you want to know more, or if you have questions, please come to my table during the conference on Thursday afternoon. Okay, thank you for watching.